Welcome to part 2 of common apparatus found in the chemistry lab. By the end of this lesson, you will be able to explore the common apparatus found in the science lab and their uses. Let's look at the flasks. The flasks that we have in the lab are as follows. So this one, we're going to label it A so that you follow nicely. This one will be B, this one will be C, and this one will be D. So these flasks, they have names. A is called a conical flask, B is called a round-bottomed flask, and C is called a volumetric flask, and then we have D is called a flat-bottomed flask. So this one is D, which is called a flat-bottomed flask. Then this is C, which is called a volumetric flask. Now, these flasks, they are used in a lot of things, a lot of chemical reactions. So let us find out their appropriate use. When do you use which flask? So let's start with a conical flask. A conical flask is used for mixing liquids while shaking. This is especially useful during a titration. So this is especially useful during a titration. A round-bottomed flask. The shape of the round-bottomed flask enables uniform heating of the liquid it contains. Therefore, it is suitably used for heating liquids for longer periods. So a round-bottomed flask is suitably used for heating liquids for longer periods. Flat-bottomed flask. Flat-bottomed flask can stand on the table, hence it is used in carrying out reactions involving a solid and a liquid. So used in carrying out reactions involving a solid and a liquid. Then we have a volumetric flask, very important flask in the lab. A volumetric flask or measuring flask or graduated flask is a piece of laboratory apparatus calibrated to contain a precise volume. For example, this one has been calibrated to only contain 500 mL of a liquid. So it can only contain 500 mL, nothing less, nothing more. And this is why it has a mark here. So this one is used for precise dilution and preparation of standard molar solutions. So please take note, this one is very important. A volumetric flask is used for precise dilution and preparation of standard molar solution. Now, what do we mean by standard molar solution? So a standard molar solution is a solution whose concentration you know. So if you want to prepare maybe 2 molar concentration, then you can use this one because you know the concentration. So if you want to determine the concentration of something, then you can use a volumetric flask to prepare such a concentration. We have beakers. Beakers are very useful lab apparatus. They are used for various uses such as for heating. Remember in the other video we talked about when you are heating with a Bunsen burner, put on a tripod stand, and then a beaker you can put on top of the wire gauge that is placed on top of the tripod stand. Okay, so for heating liquids on tripod stands and wire gauge. They are also used for mixing liquids while using volumes which are too big for what? Test tubes. Beakers are found in different sizes as well. So please take note of this one. Beakers are multi-purpose. They can be used for heating liquids. They can be used for mixing liquids while you are using volumes that are too big for test tubes. Let's look at beaker tongs. So a beaker tong, remember we've just said a beaker is used for heating. Okay, when you're heating a liquid, you put a liquid in the beaker and then you put a beaker on top of the tripod stand and wire gauge. Now, when removing that beaker from the heating point, it is going to be hot. So that is why you need a beaker tong. So a beaker tong is used to hold and move beakers containing hot liquids. Because if you touch them with your hands, it can easily cause damage to your hands. Okay, let's look at test tubes. test tube holders and test tube racks. So here we have, these are test tubes, okay, and then the wooden part here is a test tube rack, and then this one here is a test tube holder. So a test tube is used for heating and mixing liquids or solids. So a test tube is used for heating and mixing liquids or solids. Now, can I just make mention? So usually a test tube should ordinarily be used for mixing liquids. Now, there is a different type of a test tube which is a little bit bigger and has got a thicker Pyrex glass. That one we call it a boiling tube. So there is a type of test tube which we call a boiling tube, and that is the one that is used for heating. But a normal test tube is supposed to be used for what? Mixing liquids or solids that can fit in there. So a test tube rack is used for storing test tubes during an experiment. So when you're doing an experiment, you put some solution in here, you want to refer back to it, you can put it standing using a test tube rack. Okay, so a test tube holder is used for carrying test tubes containing hot solutions. So this one, when the boiling tubes are hot, you can use it for carrying them instead of using your naked hands or your bare hands. Litmus paper is one common apparatus found in the lab as well. So this is a special type of paper made up of wood cellulose infused with litmus, which is a water-soluble mixture of different dyes extracted from lichens. Litmus papers are used in laboratories and are typically cut in the shape of stripes and are used as a pH indicator. Okay, pH indicator. Do you want to know whether this thing is a liquid, whether this liquid is an acid or an alkali? So there are two types. We can use a red litmus paper or a blue litmus paper for finding out whether something is an acid or a base. Okay, the main function of a litmus paper is to determine whether the given solution is acidic or basic. We also have a mortar and pestle. So mortar and pestle. So ladies and gentlemen, these things they will ask you in the exam. There are questions where they will just bring mortar and pestle and ask you to label which one is the pestle, which one is the mortar. So please take note. We have the pestle and then we have the mortar. So what happens is a mortar and pestle is a set of two pieces. The pestle is shaped like a club and is used for crushing. The mortar is the ball in which you place the chemical. So you place a solid into this ball, which is called the mortar, and then the pestle is used for striking at that particular solid so that you can crush it. A mortar and pestle is used for crushing up solid chemicals into smaller pieces or to grind solids into fine powder. This makes it easier to dissolve solids into solvents when making solutions. We also have a crucible. So a crucible is a small container made up of ceramic or metal. A crucible is able to withstand high temperatures and therefore it is generally used to melt elements. So a crucible is generally used to melt elements. One of the most common applications of crucible lies in gravimetric chemical analysis. We also have an evaporating dish, which is used for drying substances or keeping them free from moisture. Evaporating dish, you put your solution in here and then you allow it, you put it on the sun or in the oven, and then as the water will be going out, whatever will remain dry. Okay. So let's look at these three. We have mortar and pestle, we have the crucible, then we have the evaporating dish. So it's very important that you note the difference amongst these three things. So mortar and pestle, it comes as a set. Okay. Then the real difference will be, the real confusion might be on the crucible. This is a crucible, and then this is an evaporating dish. So an evaporating dish usually has a mouth. Okay, it has a mouth. It has a lip like this. Then usually this one is just a bowl which doesn't have any mouth. But in case it had a mouth, just in case you found one with a mouth, remember, it also comes with a what? With a lid. But when they don't have a lid, you notice that this one is just all round, and then this one has got a pinched lip. Okay, this one has got a pinched lip, so you can tell the difference between these two due to the pinched lip. We also have what we call a desiccator in the lab. It looks like a pressure cooker, but it is made up of very hard glass. So desiccators are sealable enclosures containing desiccants used for preserving moisture-sensitive items such as cobalt chloride paper for another use. So a common use of the desiccator is to protect chemicals which are hygroscopic or which react with water from humidity. Separating funnel. A separating funnel is used to separate immiscible liquids. Now, immiscible liquids are liquids that cannot mix completely to form a homogeneous mixture. For example, if you get cooking oil and water, no matter how much you shake them in trying to mix them, they will still not mix when you allow them to stand. So it has a tap here. So when you put your mixture of cooking oil and water, for example, what is going to happen is after some time, you can also put this one. This can also actually be put on a clamp stand. Okay, it can also be put on a clamp stand and then allowed to stand for some time. So what you're going to notice is the two mixtures, they are going to form a layer. So you find that here, going down here, we're going to have a layer of water. And then on top here, we are going to have another layer of cooking oil. So there will be a clear-cut difference there. And then you can simply open the tap gently and allow the denser liquid to flow out, and then you close the tap. And that's how the separation can be done. So separating funnel is used to separate immiscible liquids. Examples of immiscible liquids include cooking oil and water, or liquid air, okay, liquid air, or petroleum. So all those are examples. You know, petroleum, there is petrol in there, there is diesel in there, there is paraffin in there, etc., etc. So all those, they are immiscible. They cannot mix completely. You can also talk about liquid air. We've got the oxygen in there, the nitrogen, etc. Those things can separate because they've got different boiling points as well. So a separating funnel, the bottom line is immiscible liquids. Then we have a stopwatch. A stopwatch is a device used for measuring time. So in the science lab, it is usually used to determine rates of reaction, how long an experiment takes. The SI units for time is seconds. So this is advantageous compared to an ordinary watch because of the start and stop function and the reset functions approximately. So it has got a start and stop function, and then it has got the mode here. You can reset it and set it to what you want. So it's more advantageous to an ordinary watch, although modern watches, they have also tried to include this function also. Even the phone is able to have what we call a stopwatch. Then we also have a thermometer. Okay, we call it a laboratory thermometer because it is used in the lab. So a laboratory thermometer is used to measure temperatures. So the SI unit for temperature is Kelvins, K. Okay, so despite the thermometer being calibrated in degrees, there is need to convert these into Kelvins. I think in physics, you are going to look at how to convert from degrees Celsius to Kelvins. We also have a Liebig condenser. This apparatus is used to convert vapor back to a liquid. Okay, so a Liebig condenser is used to convert the vapor. So meaning when you are heating something here, the vapor will rise, will enter in here. So as the vapor is entering in here, this thing will be connected to cold water. Okay, so cold water will be coming in from the bottom, and then when the water works in here, so it's like the way the pen is. So there is a pipe inside here. Inside this whole thing, there is a pipe. Okay, there is a pipe inside here which goes all through. So there's a pipe which goes all through like that, and then the water it passes outside this pipe. So when the vapor is passing through and the cold water is coming in, what happens is that cold water is going to be removing the energy from the from the gas particles, and it will be bringing the particles closer together, hence converting the gas back to a liquid, and this is known as condensation. So the liquid condenser is used to condense the gas or vapor back to a liquid, and this is used mostly during the distillation process. We also have a spatula. So a spatula is a flexible metal, plastic, or rubber utensil, and it is used to scoop, lift, spread, or mix substances. In case you have forgotten in case you forget the function of the spatula, think of it as a spoon of the lab. So whatever you use a spoon for at home, we do that with a spatula, except eating, of course. We do not eat anything in the lab. So a spatula is the spoon of the lab. So you can use it for scooping, for mixing, and so on and so forth. So the use is to scoop, lift, spread, or mix substances. Then we have an electronic balance. An electronic balance is an instrument. So this instrument ordinarily called a beam balance. Okay, so some people still call it a beam balance, but since this modern one uses batteries, it is called electronic balance. Okay, so under normal circumstances, it is just called a beam balance. But because this one uses batteries or sometimes electricity, it is called an electronic balance. So this instrument is used to determine the mass of objects, okay? So you just get, if it's a solid, you just get and put it here and you take your readings from there. But if it's a liquid, you first have to put it in a beaker or any container, and then that's when you put it here. You can't put a liquid directly here, okay? So generally, we are saying an electronic balance, which is called the beam balance, is used to measure the mass of objects. So just to show you the history, this is the beam balance. This is where we come from, the beam balance, and this one is called a triple balance. So all these guys, they are used to measure, they are used to measure mass, but I think at the moment as we are speaking, these are just found in some very old laboratories as souvenirs or maybe in museums, just to show you where we are coming from. We also have droppers. Droppers can be made of different materials. Just out of curiosity, a pipette can also be called a pipette. A dropper can also be called a pipette. So a dropper can also be called a pipette when it comes to chemistry. Okay, it is also acceptable to call it a pipette. So droppers can be made of different materials, either plastic, rubber, or glass, but their purpose is drawing in a liquid and expelling it in drops. So also you squeeze here, this side is rubber. When you insert this into the liquid, so you insert it into the liquid, you put it into the liquid, and then you squeeze here. Once you release, the liquid is going to go in, and then you carry it to where you are going. So if you want to be putting it drop by drop, so you squeeze it once, it drops once. You squeeze it once, it drops once. That's how it works. So here is where the secret is. When you insert it into the liquid you want to get, you squeeze it, you release it, the liquid goes in. Then when you want to drop, you just squeeze it once, the drop comes out. Thank you for listening to this video. Very important one. Every scientist needs to know the apparatus because you can never have science without experiments.